Okay, we're going to be working on transformations on the coordinate plane, section 4.2. Remember that I told you needed to have graph paper. So if you do not have graph paper, pause the video and go get it right now. We need to do graph paper for this lesson. Okay, transformations are movements of geometric figures. So we're moving triangles, squares, any kind of geometric figure on the coordinate plane. We have two terms we need to talk about. The pre-image is what we're going to call the position of the figure before the transformation. And the image is the position of the figure after the transformation. In other words, it's the new image that we're working with. The pre-image, we're going to keep those in red today. And our post-image, our images, are going to be worked in blue. So red is going to be our pre-image, and blue will be our image after the transformation. There are four kinds of transformations we're going to look at, and I'm going to list them all for you, and then we'll take a look at them one at a time. The first is a reflection, where the figure is flipped over a line. And this will make sense once we get there, so just copy these down and then we'll come back. A translation, the figure is slid in any direction. We're going to slide it right and left, we're going to slide it up and down. Dilation, the figure is enlarged, like blown up, bigger, or reduced, but it's not moving its position. And the last is a rotation, where we're going to turn the figure around an ordered pair, around a point. Usually, in our case, we're going to use the origin as our rotation. Okay, so let's take these one at a time. Pause the video if you need to write that down. Okay, the reflection. A figure is flipped over a line. So let's take a look at our pre-image in red. It's got the ordered pairs 1, 1, 5, 1, 5, 5, 3, 5, 3, 3, and 1, 3. So draw the pre-image. If you want to use colored pencils, that's fine. If not, that's okay as well. And we're going to flip this pre-image over the y-axis. So I'm going to imagine picking that up and flipping it right over the axis, or folding the paper in half. And so then I'm going to create an image after the reflection. So let's take a look at our image ordered pairs. And you need to be putting all these ordered pairs on your notes. So 1, 1 comes over here to negative 1, 1. 5, 1 comes over here to negative 5, 1. 1, 3 comes over to negative 1, 3. 3, 3 gets reflected all the way over to negative 3, 3. 3, 5 gets reflected over to negative 3, 5. And 5, 5 gets reflected over to negative 5, 5. So let's take a look at these ordered pairs and see what happens when we do a reflection, a mirror image, over the y-axis. So I'm going to list these ordered pairs. 1, 1 changed to negative 1, 1. 5, 1 changed to negative 5, 1. 5, 5 changed to negative 5, 5. I hope you're seeing a pattern. 3, 5 changes to negative 3, 5. And 1, 3 flipped over to negative 1, 3. So when I flip over the y-axis, we notice that the y value doesn't change. It just goes from side to side. But since the x is going, in this case, from the positive to the negative, it changes signs. We want to write a general rule for reflection over the y-axis. And our general rule is that our xy ordered pair, all of the ones over here, change to negative x, y. Okay? What if we did a reflection over the x-axis? So this time I'm going to reflect on the x-axis. I'm going to start with the same pre-image, but this time I'm going to flip it down. So 1, 1 comes down to here. 1, 3 comes from this position all the way down to this position. 3, 3 comes from here all the way down to here. Continue in this pattern until you get all your points. I'm going to have you pause the video, finish your reflection, and then find the ordered pairs for your image. Okay, so this is what your image should look like. Now we're going to put our ordered pairs in. So now I have 1, -1. I have 1, -3. I have 3, -3. 5, -1. 5, -5. And 3, -5. So again, let's take a look. This is our pre-image here. And I'm going down to this image, reflecting it over the x-axis. Now there's a lot of points here. I'll do fewer on the next picture, but we've got 1, 1 goes to 1, -1. We've got 5, 1 goes to 5, -1. We've got 5, 5 goes to 5, -5. We've got 3, 5, which flips over to 3, -5. And we have 1, 3, which reflects over to 1, -3. So again, let's find a rule. What do you think xy is going to change to? Hopefully you said x, -y. So these are our two rules for changing an ordered pair by doing a reflection. The first one is a reflection over the y-axis, and in that case the x changes, and when we reflect over the x-axis, my y values change. Let's look at another one of these that doesn't start just in the first quadrant, because that makes things a little bit different. Okay, so let's start with the figure that has a point at 2, -1. Whoops, this is going to be my pre-image. I want to do this in red so that we stay consistent. 2, -1. We're going to have a point at 5, 5. So that's up here. And we're going to have a point at -1, 2, which is over here. So there's my pre-image in red. Now I want to reflect this over the y-axis. Okay, so I'm going to take my blue and let's see what happens. So if I take my point 5, 5, and remember my rule was that xy for my y-axis goes to -xy. So I'm going to take this and flip it all the way to the other side, and it's going to come over here to -5, 5, which is my rule. 5, 5 goes to -5, 5. 2, -1, it's going to come over here, and it's going to become -2, -1. So 2, -1 goes to -2, -1. What about this one? It's starting on the left side, so if I'm going to reflect it, I need to reflect it to the other side. So it's going to go, oops, I'm sorry, I should not have connected those two down here. My bad. No, let me get rid of it. Come on. I'm having trouble with my eraser today. Let's see what I can do. There we go. I'm sorry. Okay, so this one comes to here, -1, 2, comes to 1, 2. Again, I'm still reflecting it over the y-axis, but it has to go from left to right instead of right to left. So let's see what happened there. -1, 2 went to 1, 2. Let's think about that for my rule. xy goes to negative xy. So again, looking at this point, negative 1, 2, I need to go to the opposite of x. So instead of writing negative 1 for x, I'm going to write the opposite of negative 1, which is positive 1. So don't get confused. That sign does not mean negative. It means change the sign. It's the opposite of whatever we started with. And if I connect my 3 dots now on my image, I can see, excuse me, wow, something happened. There we go, my bad. There we go. Okay, so we can see that our pre-image got flipped over to our new blue image. Okay, we'll practice some more of these in class. We've got a couple more to look at though. So we have 2 rules so far. Reflection over our x-axis. Make sure you have that rule written down. I'm having trouble with my forwards and backwards. I apologize. There we go. So reflection over the x-axis, that's my first rule, and reflection over the y-axis, that's my second rule. All right, translation. We're going to slide a figure. So again, let's call, and I'm going to change the colors up on this a little bit. Let's call this figure our pre-image. And we're going to slide it. You notice that it hasn't rotated. It hasn't flipped upside down or backwards, but it's moved its position. So let's take a look again at our pre-image. And our pre-image in this case has the ordered pairs 1, 1, 6, 5, and 7, 1. So 1, 1, 6, 5, 7, 1. And that's going to change to our image, which in this case is negative 1, 4, where am I? 4, 8, and 5, 4. So my 1, 1 has moved that way to negative 1, 4. My 6, 5 has moved to 4, 8. And my 7, 1 has moved to 5, 4. So do we see a pattern here? Well, let's look at what's happening. I have to slide right and left or up and down. So if I take my 1, 1 point, I'm going to pick a new color for my slide. If I slide to the left 2 and up 3, that's my slide. When I go to the left 2, I am changing my x value by negative 2. When I am sliding up 3, I am changing my y value by 3. So let's take a look at that. If I take my original x value, my 1, and I take away 2, I get negative 1. If I take my original y value and I go up 3, I end up at 4. Let's see if it works for the others. If I start at 6, 5, if I take my x and slide it to the left 2, I subtract 2 to get 4. If I take my y and go up 3, I add 3 to get 8. Check and see if the last one works. 7 minus 2 is 5. 1 plus 4, or plus 3 is 4. So in this case, in this particular case, my change was to subtract 2 from my x and add 3 to my y. So my general rule for a translation is that I will add or subtract. I'm going to put them both. We've used this notation before. Either one, not both at the same time. I am going to add or subtract some number, and I'm going to add or subtract some value to my y. Okay, let's try one of these together. So let's put a pre-image up. I'm going to use red again. And I'm going to put a pre-image at -1, 4. I'm going to put a dot at 3, 3. Boy, I am having trouble today. I apologize, guys. I'm going to put a dot at 1, 1. And I'm going to put a dot at -3, 0. So I've got kind of a funky little four-sided shape here, a quadrilateral. So that's my pre-image. So I've got -1, 4, 3, 3, 1, 1, -3, 0. And I want to translate this. I want to go to the right 4 and down 2. So using my rule, to the right on the x-axis is a positive direction. Down on the y-axis is a negative direction. So I'm going to take my x, I'm going to add 4, that will move it to the right 4, add 4. And I'm going to take my y value and go down 2, moving it to the left, or excuse me, moving it down, taking away 2. So without drawing the picture, try to do your translations, your shifts, using this algebraic model. Then we'll come back together. Okay, so if I add 4 to -1 and I subtract 2 from my y, I will get the ordered pair 3, 2. So let's put 3, 2 on my graph. Okay, 3, 3. Again, adding 4, subtracting 2, I get 7, 1. So 1, 2, 3, 4, 5, 6, 7, 1. Oh, wait, I put 3, 2 in the wrong place. I hope you caught me. That's better. So I've got 3, 2, and I have 7, 1. Hopefully for your other points, you got 5. 1 plus 4 is 5. 1 minus 2 is -1. -3 plus 4 is 7. 0 minus 2 is -2. So 1, 2, 3, 4, 5, -1. And, oh my goodness, I am making all kinds of mistakes, guys. I just went to graph this and realized how far off I was. -3 plus 4 is just +1. -3 plus 4. I'm having all kinds of trouble with my pen. No, I'm just going to have to, there we go. So -3 plus 4 and 0 minus 2. My apologies. Now I've got it right. So 1, -2. So let's take a look if I connect these. Hopefully I've got it right now. We can see that I have the same shape, but it's moved to the right 4 and down 2. All right, let's see if I can do a better job. That was our translation. Next rule, dilation. The figure is enlarged or reduced. You can tell that our pre-image in red has been blown up. It's bigger than it was. It's also a little further away from the origin. So we are blowing it up or enlarging it with respect to the origin. So going back to my red, let's label these ordered pairs. 2, 3, 2, -2, and -1, -4. Pause the video and get that pre-image down. Okay, so this is our pre-image. So I've got the ordered pairs are 2, 3, 2, -2, and -1, -4. Now pause for a minute and draw your image and the ordered pairs for it. Okay, so we should have now 4, 6, 4, -4, and -2. This is off. 6, 7, -1, -4. This should have been at -8. Drop it down on your picture. That should have been at -2, -8. This slide that I used is not right. So 2, 3 has changed to 4, 6. 2, -2 has changed to 4, -4. And -1, 4 has changed to -2, -8. Now you should be pausing frequently during this slide because it's going to take you time to write these down and get your pictures correct. Okay, can you see a pattern in what has happened here? So the pattern that I see is that my x, y has been doubled. Every single ordered pair has been multiplied by 2. So this post image is twice as large, or it has been doubled. And to do that, I have multiplied both the x and the y by 2. So our general rule for our dilations is that my xy goes to some number times x and the same number times y. That's my general rule. Let's take a look at another one of these. So again, once I get this figure up, make sure that you have got it on your screen properly. I'm going to start with my red from my pre-image. So I'm going to start with a figure at -3, 3, 3, 6, 1, 2, 3, 4, 5, whoops, 3, 6, and 6, 0. 1, 2, 3, 4, 5, 6, 0. So that's going to be my pre-image. I'm going to put my ordered pairs over here. Come on. Okay, so I've got -3, 3. I've got 3, 6, and I've got 6, 0. And I want to reduce this by 1/3. In other words, I want to make this 1/3 as large as the original. So I'm going to take, to get my image, and I'm going to multiply by 1/3. So I'm going to take 1/3 times -3 from my x and 1/3 times 3 from my y. So that should be -1, 1. In other words, I'm dividing by 3. Multiplying by 1/3 is the same as dividing by 3. I'm reducing the image to 1/3 as large. So for this one, I get 1, 2. For my last one, let's see if we can do it without writing the in-between steps. 6 times 1/3, or 1/3 of 6 is 2. 0 times anything is 0. So let's look at our image. -1, 1, 1, 2, and 2, 0. So it has been shrunk. It is 1/3 the size, and if you notice that it shrinks closer to the origin. Everything comes closer to the origin when it shrinks. Notice that we're not shrinking it up in the middle here somewhere. Okay, we are shrinking it down and making it closer to the origin and smaller in size. So again, our general rule here for dilation and for dilations, which can be bigger or smaller, is some number times x, the same number times y. Okay, we have two more general rules to look at, so be patient. Rotation. The figure is turned around a point. We are going to turn around the origin. Our first example is a rotation by a 90 degrees, a 90-degree rotation. So what we're doing, and I'm going to put my blue in and red in. So this is going to be our pre-image, and this is going to be our post-image. And they've done all the order pair work for us on this slide. Okay, so copy the picture down, put the order pairs in. If you want to list them the way they did, or if you want to put them at the vertices, that's fine. But get all that work down, and then we will take a look at this together. So pause and do that. Okay, so our pre-image was 1, 1, 1, 5, and 4, 5. And let's take a look at point B, and so we can see exactly what they're doing. You don't have to draw these red lines on your graph, but it's showing you that if I take point B down to the origin and do a 90-degree angle and bring it back out the same distance, these two lines from here to here and here to here are the same distance, and we have a 90-degree change. We will end up at, instead of 1, 5, I will end up, back to my blue, I will end up at negative 5, 1. My 1, 1, doing a 90-degree rotation at the origin, ends up at negative 1, 1. And my 4, 5 here, if I do a line down to the origin and out to here, that's my 90 degrees. My 4, 5 changes to negative 5, 4. Can we see a pattern here? Take a moment and see if you can see a pattern. Look at the last two in particular, because the first one is both 1, so it's hard to see what's happening. So pause for a moment if you need to. If you already see the pattern, great. All right, let's see if you got it. Let's see what's happening. XY is going to, they switch position, and the Y gets the opposite sign. So an XY goes to negative YX. So this one's a little bit trickier, but that's my 90-degree rotation general rule. And again, I should really say that that's the opposite of Y. XY goes to the opposite of Y, comma X. Let's look at our last rotation, which is a 180-degree rotation. And my rule is a little different. Again, take a minute to write this all on your paper. We're going to use this triangle up here as our pre-image, and we're going to use this triangle down here as our image after our rotation. Okay. Do not continue if you haven't written that picture down in detail on your graph paper. Pre-image, 0, 1, 4, 1, 2, 5. Again, they've shown an example with point B, where they've taken it straight through the origin. This is a 180-degree rotation all the way through our origin. So this point B has rotated all the way around to our new B. So let's see what our new ordered pairs are. So 0, 1 was my A. It has gone to 0, negative 1. 4, 1 has gone to negative 4, negative 1. And 2, 5 has gone to negative 2, negative 5. So what's our general rule or pattern for a rotation of 180? XY is going to go to the opposite of X, the opposite of Y. Okay, so let's summarize our rules. Let's go back to that very first slide. Go back to our very first page of notes. Let me get back there. And let's do some of our rules. Reflection, we have two of them. Our x-axis reflection is that xy goes to the, I'm sorry, I misspoke again. Y-axis reflection. xy to the opposite of xy. And our x-axis rotation goes from xy to x, comma, the opposite of y. A translation, xy, we're going to add or subtract some number from x and add or subtract some number from y. They don't have to be the same number. Our dilation, we take each point from the ordered pair and we multiply it. You saw that we could multiply it by a whole number. We can multiply it by a fraction. And then our last two are 90-degree rotation. X, y goes to the opposite of yx. They switch position and the y changes sign. And our 180-degree rotation, both of our values change their sign. So there's our summary. The more you work with these, the easier they become. I know this was a pretty lengthy video. I appreciate you hanging in there, and I'll see you in class.